Given a 4 by 4 matrix, let's calculate its determinant. So since it is a 4 by 4 matrix, a square matrix, its determinant can be found. Let's recall a nice formula allowing to calculate a determinant of any size, and it goes like this. Delta, which is a determinant, equals a sum for I or j for I or j from 1 to n of -1 to the power of I plus j times a sub ij times m sub ij, where I is the number of the row, j is the number of the column, n is the number of rows or columns in the given matrix, a sub ij is the entry of the given matrix number ij, and m sub ij is the corresponding minor. Now, let's take a look at our matrix. As we can see, it doesn't have any zero entries, so we can pick any row or column we want. And I suggest that we picked the first column. It means that we're setting j to 1. Also, since our matrix is of the size 4 by 4, n equals 4. So considering this, our formula is transformed into the following. Delta equals sum for I from 1 to 4 of -1 to the power of I plus 1, since we've set j to the value of 1, times a sub I1 times m sub I1. Now, if we expand this sum, we'll obtain the following. -1 to the power of 1 plus 1 times a sub 1, 1, and I can substitute that right away since a sub 1, 1 equals -1, and we know that. Times minor m sub 1, 1. Plus, wasn't such a good idea for me to start here, so I'm just gonna move a little bit to the left. Okay, here it goes. Again, -1 to the power of 1 plus 1 times -1, which is a sub 1, 1, times m sub 1, 1, plus -1 to the power of 2 plus 1 times a sub 2, 1, which is 2, times m sub 2, 1, plus -1 to the power of 3 plus 1 times a sub 3, 1, which is 1, plus times m sub 3, 1, and plus -1 to the power of 4 plus 1 times a sub 4, 1, which is 3, which doesn't need any brackets, times m sub 4, 1. Now, -1 to the second is simply 1 times -1 is -1, so we have -m sub 1, 1. Then, -1 to the third is -1 times 2 is -2, so we subtract 2 times m sub 2, 1. Then, -1 to the fourth is simply 1 times 1 is 1 again, and we add m sub 3, 1. And then we have -1 to the fifth, which is -1 times 3 gives us -3. So we have -3 times m sub 4, 1. So we now have to calculate 4 minors, m sub 1, 1, sub 2, 1, sub 3, 1, and sub 4, 1. I'll write down that formula separately so that we won't lose it or forget it. So So determinant of our matrix will be calculated by this formula. Negative m sub 1, 1 minus 2 times m sub 2, 1 plus m sub 3, 1 minus 3m sub 4, 1. Now we need to calculate these 4 minors, and those 4 minors are 4 determinants of the size 3 by 3. Let's start from m sub 1, 1. And that is a determinant of the size 3 by 3, which is formed from the initial matrix by crossing out the first row and first column from it. So it is determinant, the following determinant: negative 1, 2, 5, 2, 3, 4, 4, negative 1, 2. We'll use the same formula to calculate this determinant, since it works perfectly for determinants of any size. And again, we're dealing with a determinant which has no zero entries, and that means that we can pick whichever column or row we'd like to calculate this determinant. And I suggest that we picked the first row. It means that in this formula, we're setting I to a value of 1, so j changes from 1 to 3 this time, because our determinant is of the size 3 by 3, and n equals 3. So we'll go like this. Negative 1 to the power of 1 plus 1. That's better. Negative 1 to the power of 1 plus 1 times negative 1 times the determinant which is left, and that is 3, 4, negative 1, and 2. Plus negative 1 to the power of 1 plus 2 times 2 times the determinant which is left, and that is 2, 4, and 4, 2. And then plus negative 1 to the power of 1 plus 3 times 5, and times determinant 2, 3, 4, and negative 1. We may remember that determinants of the size 2 by 2 are found by subtracting the product of the elements lying on the reverse diagonal from the product of the elements lying on the main diagonal. Let's see. We'll have negative 1 to the second, which is 1, times negative 1, which is negative 1, multiplied by this determinant, which is calculated like this: 3 times 2 minus negative 1 times 4. Then negative 1 to the third is negative 1 times 2, gives us negative 2. And we multiply it by this determinant, which is 2 times 2 minus 4 times 4. And then we have negative 1 to the fourth, which is simply 1, multiplied by 5 is 5. So we add 5, multiplied by 2 times negative 1 minus 3 times 4. So we have negative 6 minus 4 minus 2 times 4, which is 8, and then plus 32, and then minus 10, and minus 60, which is equal to negative 56. And that is our first minor. 1, 1 equals negative 56. Now to the second minor, m sub t1. And that is a determinant of the matrix, which is obtained from the initial matrix by crossing out second row and first column. So that is 1, 4, 2, 2, 3, 4, 4, negative 1, 2. And we'll use the same method as we did for m sub 1, 1. So we're picking the first row, and again, I is set to a value of 1, n equals 3, and j changes from 1 to 3. So we have negative 1 to the power of 1 plus 1 times 1, and times 3, 4, negative 1, and 2, plus negative 1 to the power of 1 plus 2 times 4 times 2, 4, 4, 2, and plus negative 1 to the power of 1 plus 3 times 2 and times 2, 3, 4, minus 1. So, negative 1 to the second is 1 times 1 is 1, obviously. And this determinant is 3 times 2 minus 4 times negative 1. Then negative 1 to the third is negative 1 multiplied by 4 is negative 4. So we subtract 4 multiplied by 2 times 2 minus 4 times 4. And then we have negative 1 to the fourth, which is 1 times 2, with these 2, multiplied by 2 times negative 1, minus 3 times 4. Now let's see, we have 6 plus 4, which is 10. Then we have minus 4 multiplied by 4 minus 16, which is negative 12. And then we have 2 multiplied by negative 2 minus 12, which is negative 14. Then plus 48 and minus 28. And that is equal to 30. Our second minor, m sub 2, 1 is equal to 30. Minor m sub 3, 1 is a determinant of a matrix obtained from the initial one by crossing out its third row and first column. So we have 1, 4, 2, negative 1, 2, 5, 4, negative 1, and 2. And using the same method as previously, we obtain negative 1 to the power of 1 plus 1 times 1 and times determinant of 2, 5, negative 1 and 2, plus negative 1 to the power of 1 plus 2 times 4 times negative 1, 5, 4 and 2, plus negative 1 to the power of 1 plus 3 times 2 and times negative 1, 2, 4, negative 1. Negative 1 to the second is 1 times 1 equals 1, so we have only this determinant, which is 2 times 2. Let me calculate it right away. So we have 2 times 2 is 4, minus negative 5, so we have plus 5 over here. Then, negative 1 to the third is negative 1 times 4 gives us negative 4, which goes multiplied by negative 2 minus 20. And then, negative 1 to the fourth is 1, goes multiplied by 2, so we have plus 2, which is multiplied by negative 1 times negative 1, which is 1, minus 8. So we have 9 plus 4 times 22, which is 88, and then minus 14. And that is equal to 75 plus 9, which is 83. And that is our third minor. M sub 3, 1 equals 83. The last minor, M sub 4, 1, is a determinant of a matrix obtained from the initial one by crossing out fourth row and first column. And that is 1, 4, 2, negative 1, 2, 5, 2, 3, 4. And that is equal to negative 1 to the power of 1 plus 1 times 1 times determinant of 2, 5, 3, 4 plus negative 1 to the power of 1 plus 2 times 4 and times determinant of negative 1, 5, 2, 4 and plus negative 1 to the power of 1 plus 3 times 2 and times determinant of negative 1, 2, 2, 3. Negative 1 to the second is 1 times 1 gives us 1, and then this determinant is 8 minus 15. Then negative 1 times 4 gives us negative 4, which goes multiplied by negative 4 minus 10. And then negative 1 to the fourth is 1 times 2 gives us 2, so we have plus 2 multiplied by this determinant, which is negative 3 minus 4. So we have 8 minus 15, which is negative 7, then we have negative 4 multiplied by negative 14, and that is positive 56, I suppose. Right? And then minus 2 times negative 7, which is negative 14. And so we have 42 minus 7, and that is, I suppose, 35. Right. So our fourth and last minor, M sub 4, 1. Is equal to 35. Now we need to substitute them into this formula. our matrix A is equal to negative minor m sub 1, 1, and that is negative 56, which gives us positive 56. Then we subtract 2 times minor m sub 2, 1, which is negative 2 times 30, so we subtract 60. Then we add minor m sub 3, 1, and that is 83. And then we subtract 3 times minor m sub 4, 1, and that is 35. So we have negative 4 plus 83, which is 79, minus 105. And that is equal to, I need a second here. 21 plus 5, negative 26. And that's our answer.